Hi, good evening, everyone. How are you all doing? If you can hear me, use the chat to interact. You can use the chat to interact. Am I audible? Good evening, everyone. Okay, I've got some replies. Okay, how are you all? How are you all doing? Good evening, good evening. Good. Okay, great to know that you are all doing great and good. So, welcome to the today's session of Honeywell Future Ed Skills Program. So, let me quickly start it. Give me a minute. Okay. So, so as you all know about the program, that it is a flagship CSR initiative where we are trying to empower 2 lakhs youth for the future ready skills. So, I won't spend much of the time towards the next slide, that is the session hygiene rules. So we I'm quickly highlighting few of the points for the session hygiene rules. First thing, please always join on time. Don't be late. Second thing, please use your real names while you are joining so that when we are interacting, I should know by your real names as you know by my real name, right? So that we can interact effectively. Then do not share any personal information or sensitive information in your chats, and you have to actively participate in the throughout the session of 2 hours using chat option because you cannot speak, right? So use the chat options when you are interacting with me, and also keep a notebook and pen with you so that you can note down the important pointers because we know that whenever we note down something, we remember it for a longer duration, right? So these are some quick pointers. Let's move on to our today's session. So the agenda of the today's session is, firstly, we will be doing the recap of what you have covered in the previous sessions. Then today, as you studied about algorithm, supervised learning type of machine learning, that was supervised learning. So we would be moving on to that. And we will see different algorithms under supervised learning, and we would do practical demonstration with no coding accompanied with lot of quizzes and questions, right? So let's move on to our first thing. Scan the QR code which is there on the screen and fill out the form so that I know that how we can proceed with the session. And this is not a test, this is just a quick form to know what how much you know about what we are going to study, right? So quickly scan the QR code and mention done in the chat once you are done with filling out the form. I am looking at the chat. Once you are done, mention done in the chat. Fast 30 more seconds. Okay, Kashish has done. Others, where are you all? Once you have scanned, filled out the form, mention done in the chat. Okay, I can see many done. Sabraj done. Varun done. Okay, now I can see a lot of done. Great. Sakshi done. Okay, so we are moving further with our first thing, that is recap. So first I want to ask from you guys that what machine learning actually is for you in one line. What you understand by machine learning. Be active in the chat. See, I get many replies in the chat. I will only respond to the few which is on the top because I cannot reply to 50, 60 people in a single go. So be quick when you are replying to me so that I can respond accordingly. So what do you understand by machine learning? In one line, whatever you have studied in the previous session. Okay. Any idea what machine learning is? You have attended previous sessions, right? Or all are blank? All are sitting blank, no answers. Okay, so let me give you a quick recap like what machine learning was. Machine learning is basically when we teach the machines to learn from the data without coding or without doing programming even a single rule, right? So जब हम मशीन को स्टेप बाय स्टेप्स इंस्ट्रक्शंस देते हैं, हम उसे एग्जांपल्स देते हैं और वो खुद पैटर्न सीख लेते हैं, राइट? दैट इज व्हाट मशीन लर्निंग इज. जस्ट लाइक when we are teaching a child that if I'm teaching a child that what is a dog, what is a cat, what is an apple, what is a fruit, so what I do, I will tell that child by giving the inputs, by giving different images of fruits, by giving different images of apples, by giving different images of dogs, right? So that child will start identifying the difference. So same way the machine also learns, right? And that's the beauty of machine learning. Now, my next question is from you all. As I mentioned, what machine learning is, right? So, I want to ask from you, is machine learning a part of AI or AI is a part of machine learning? What do you think? Answer quickly in the chat. Machine learning is a part of AI or AI is a part of machine learning? Be quick in the chat. Okay, I've got few replies. Meghna says ML is a part of AI. Sabrad says ML is a part of AI. Mohammed Khalid says ML is a part of AI. Okay. S says ML is a part of AI. Okay. So all of you simultaneously mentioned that machine learning is a part of AI. So we can say that AI is a bigger umbrella and machine learning comes inside it, right? Next thing, what you learned in the previous session was types of machine learning. So we had three types of machine learning. One was supervised learning, other was unsupervised, then was reinforcement learning. What was supervised learning? In simple terms, in one line, what you understood by supervised learning? You can mention in the chat. What you understood by supervised learning? Okay, let me look at the replies. Okay. Which uses label data, Mohammed says. Okay. What about others? Sakshi learns from label data. Okay. Meghna, giving both Q and A to machine, right? So supervised learning basically is when we give question and answers both to the machine. Means when we give students question paper and the answer key so that the students can learn what is right and wrong. That is what supervised learning is, right? For example, I am giving a model, there are some images and I am categorizing also that this image is a cat image, this image is a dog image, and this image is a fruit image. Right. So when we are giving correct answers, that is supervised learning. What about unsupervised learning? What do you understand by unsupervised learning? Quick in the chat. What do you understand by unsupervised learning? That was the second type you understood. Himanshi replied, learning without guidance. Khalid says learns from unlabeled data during training. Okay, so if I tell you that, I give you example. If I tell you make clusters or make groups based on the spending patterns and salary, means if मैं अब अगर आपको 10 या 100 random लोगों का डेटा देती हूँ, राइट? एज, सैलरी, शॉपिंग हैबिट्स उनके, ठीक है? एंड आई टेल यू ग्रुप देम ऑल, ग्रुप देम लॉजिकली. And I have given the data of 100 random people, age, salary, how they shop, their shopping habits. So what you will do? How you will group them? How you will group them? What you will do in that case? Quick, be a little quick when you are answering. Grouping, okay. So what we will do, we will try to make clusters. Okay, Khalid has answered. Okay, Khalid, I have asked that if I give 100 random people's data to you guys, and like age, salary, their shopping habits, and I tell you all to group them logically. What you will do? How will you group them for making the groupings or the clusters? Clustering based on labels and topics. Okay, right. Meghna says according to age. Okay. So basically, what we will do, we will try to make the groups or we can say clusters based on their spending patterns, their salary, right? So that is your unsupervised learning, where we are not giving input and output. Based on their patterns, we are grouping them, right? How your Netflix recommendations work in a similar way. Now, the last we have is reinforcement learning. What do you understand by reinforcement learning? In single line, combination of supervised and unsupervised, Shruti says. Not exactly, not exactly, but good try. What else? So basically, reinforcement learning is learning by reward and punishment method. Meghna, you are right. It learns based on feedback. Basically, reinforcement learning is when we are training for example, I'm training a dog. If it does a correct action, I give a bone as a reward. If it does a wrong action, I don't give the bone. So that is no reward. That is a punishment, right? So machine tries to make mistakes, learns and improves. That is how machine do, right? This, like we can say self-driven cars, or when a robot is learning to walk, same. And when we train a game playing AI, all these are the examples of reinforcement learning. Khalid says, which helps an agent in an environment to learn based on rewards and punishment. Right, right, Khalid, you are right. So that is what you have learned in the previous session, and also you saw uh, some demos. One of those demos was Google Teachable Machine, wherein you learned how you can train a model or build a model without using code, where you train using a bottle and a mobile phone, right? So let's play a rapid fire game where rules are simple. You have to tell me supervised, unsupervised, and reinforcement. You can write S, U, and R for respective things. So if you are ready for it, mention ready in the chat. If you are ready for it, I will start showing you the scenarios and you have to mention R, S, and U. Ready, ready, ready. Okay, now everyone is active. When I was asking questions, nobody was answering. Okay. So, first scenario on your screen, which type of learning is this? What do you think? An app groups customers into different types based on only their spending patterns. We just discussed this. Which type of learning is this? Be quick. I got the answer from Sabraj. Okay. Kalyani also answered. Who else? Anand has answered S, and others too have answered U. Himanshi, unsupervised. Khalid, unsupervised. Meghna, unsupervised. Okay, let's see what we have. It is basically a unsupervised learning because as we discussed, we are not giving the input and output. We are just telling the input that how they are spending, what are their spending patterns, and automatically app is grouping them. right? So this is an example of unsupervised learning. The next one, let's see. So which type of learning is this? Where a model is trained on many images labeled apple or orange, and then it is used to predict for new photos. Kalyani says supervised. Sabraj says supervised. Sakshi supervised. Okay, a lot of supervised. Supervised. Okay, so most of you have answered supervised learning. Let's see. So, right, it is a supervised learning. Reason being, it is already mentioned that we are training the machine on labeled data, right? So, let's see the next. What about this? When a system learns from the past students' data with labels, pass or fail, and then predicts for a result for a new student. What is this? I can see a lot of answers. S, S, S. Supervised, supervised, supervised. Okay. Anand says R, reinforcement learning. Okay, we got one different answer. Supervised, supervised. Kalyani also says R. Rest everyone is saying supervised. Tejaswini supervised. Okay, let's see. So it is a supervised learning because we are training with the labels. There is no reward, there is no feedback. It is, if we are using it for predicting the result, that does not mean we are training it with reward and feedback system, right? We are just using it to predict something that is a result. So see the difference between both. Reinforcement is when we are training the machine with reward and punishment. वो कुछ ठीक कर रहा है हम उसको रिवॉर्ड दे रहे हैं, वो कुछ गलत कर रहा है हम उसको पनिश कर रहे हैं. We are giving the negative points. Now the last, which type of learning is this? It is quite easy to guess, so fast, be quick in this. Himanshi, let me see. Kalyani has answered R. Himanshi has answered reinforcement. Meghna reinforced learning. Anand R. Okay, so most of you have mentioned R, so that's correct. This is reinforcement learning in which we are, as we discussed, it is by giving points, right? So let's move on to uh, something very light but powerful. This was what you have studied. Now I will be showing you some words in which some letters are missing. So you have to guess and complete the word one by one. First one, we will go, you can leave the first one. That is just for, let me use the pen. You can leave the first one. Move on to the second one. Tell for this one. Second, what you can guess from this? I can see 20 replies. Okay. Second one, unsupervised learning. Unsupervised learning. So I got first answer from Himanshi, then Anand, then Khalid. Okay. So I'm getting multiple responses. So these were the ones who answered very quick. So as I said, be quick in answering. Tell me about the third one. You are correct. This is unsupervised learning. You can fill it. What is the third one? Okay, Khalid answered it at the very first. Then Anand has answered it. Himanshi, done. Okay. Sakshi, okay. So Khalid has answered it first. That is reinforcement learning. Great, great, everyone. Now, tell me about the fourth one. Tell me about the fourth one. Kalyani has answered about the fourth. Disha has answered. Great. Okay, Kalyani and Disha are the top two ones. And Aditya has also answered. Great. Okay, now I'm getting multiple responses. So this is features. Eatures. Right. What about fifth? Let's see who have answered it first. Kalyani answered. Aditya answered. Okay, Aditya has given me next two also. Okay, great. So fifth one is Labels. Labels. We will study what features is. We will study what labels is in the further sessions. So this is A and this is E. Okay. So what is the sixth one? Okay, I got the answer from Kalyani, Aditya were the first ones. These two were the first ones for the sixth answer. This is data set. Wherein ATASET. Great. What is the seventh one? What is the seventh one? Aditya has mentioned. Shruti has mentioned the before Kalyani, Shruti and Aditya has answered first. This is classification. Right. What about the eighth one? What about the eighth one? Okay, I got one answer from Shruti, second answer from Aditya and Savraj. Great, great everyone. So this is regression, right? We study two types, regression, classification, and we will study also this further in this session. What is this ninth? What is this ninth? This we have discussed right now. Okay, Shruti has answered. Great. Khalid has also answered. Great, everyone. Great. So, ninth is your clustering, forming the groups in unsupervised learning. And the last one, 10th. What is the 10th? Let's see. Aditya has already answered. Rest of you. Okay, one says refers. No, refers is not the answer. Recursion, Kalyani says no. Recursion, no. Priyanka also says recursion. Okay, I'm getting this is rare. Okay. Himanshu, rare does not complete your word. Himanshi has given the correct answer, but with the S extra in end. Disha return no. You have to relate it with the AI, what you have studied, not random. There could be a number of words with the same thing. Okay, so as I said, Disha has answered. Not Disha, sorry, Himanshi has answered, right? So this is reward, which is used in reinforcement learning. So it is WARD, right? So great, everyone. You all were very quick in this. So see how quickly we have. Did you notice this? Means without reading notes, without opening books, we have just revised all the machine learning vocabulary, right? So now let's move to our today's topic, which we have from theory. We are moving to the real life. So machine learning is not just in books, right? So I want to ask from you all, where do you already see predictions in daily life around you? uh, uh, Apart from the ones given on the screens, you have to tell me something else. Where do you see predictions around you? It could be anything. Okay, Anand says cricket matches, cricket lover, great. Himanshi says astrology, right? Priyanka says weather, great, great observations. Aditya says sale price predictions, right? Khalid says Spotify, right? Great. So means you can see that we have not only one, we have predictions all over around us: stock price prediction, cricket winning prediction, loan approval prediction, or weather forecast, shopping recommendations, that is also a prediction, that which customer will like which product, Netflix recommendations, that is also a prediction, or Google map traffic, that is also a prediction, right? So prediction is everywhere, right? When we open any app, some AI model is predicting something about us, right? It's scary, but it is powerful also. If we open Instagram, it knows what we are having in mind, what we are thinking, what we have just watched in Mintra, or I have searched for a shirt in Mintra. So it will start giving me the ads in the Instagram also about the shirt. So that is how the predictions are going around us. Now imagine something interesting, like suppose someone gives you one AI model for free, and it can predict only one thing for you. Which one would you choose? Which one would you choose from this? Stock price, your exam score, chance of getting a loan, temperature of Goa, whether a new movie will be a hit or not. What you will choose? Let me see the chart. Okay, I can see weather. Khalid says exam score. Okay, very smart decision, right? Priyanka says stock market exam score 2 in 1.
So hello everyone, am I audible? If yes, you can drop the messages in the chat box. By the way, just let me rename. Okay, I'm audible now to everyone. Okay, I'm getting the messages. Yes, sir. Yes, sir. That's totally great. So actually, it seems that she's having the internet issue or the network issue. We can say basically because of that only. So till that we can have a conversation, right? So just tell me about what you have learned till yet. You have got the informations related to supervised machine learning, right? From me as well and from Miss Anjali as well, from Anjali ma'am as well, right? So how many of you clearly understood about this supervised machine learning? Just drop me your messages in the chat box. I'm looking over there. Okay, Anand says me. What about the rest? Where are you all? Okay, Priyanka says me. Sakshi says me. Okay. Okay, that's totally great. It's great, great, great. Okay, I've got another messages from Himanshi. Okay, Himanshi, you are also there. Khalid is also there, right? Okay. So give me one best example of supervised machine learning. But I don't want that a spam classification wala example. Just give me another one. Everyone, I'm looking over the chats. Okay. So can you please share your LinkedIn or WhatsApp? I can't find you on LinkedIn. You can't find me on LinkedIn. Just move to Google and on Google search IBM Gaurav Singh. You will came to know, right? So you will be directly getting there over there itself. Yeah. Just have a look. Okay. Yeah, that's totally great. Done, 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 done. Okay, I'm getting the yeah, Priyanka, email spam detection that has been already covered, except this one. Okay, she has came. Okay, Anjali, you can take the place, right?
Okay, thank you, Gaurav.
Okay.
Sorry for the pause. My laptop screen got blank sudden. So we will restart. So I was asking from you all. So I was reading out your chats. Let me get back to the same thing again. So I got answers that you would be predicting or you would like to predict what all things? Stock price, your exam scores, or the chance of getting loan, right? So that's amazing that we have a AI model which we are using it for prediction. Now, the difference is very important that what is the algorithm behind the prediction. So we are moving towards that all these predictions are same type, or how these predictions are made, or are all these predictions lie in the same category. What do you think? Are all these predictions lie in the same category? Yes or no? What do you think? Whatever predictions we are talking about, yes, yes. Okay, Priyanka says yes. What are the things? All these predictions lie in the same category. Okay, Priyanka says yes. So actually it is not true. Why? Because some predictions are giving us numbers. Himanshi says no, right? Because some predictions you can see stock price is giving me a price. That is a number, right? Exam score is a number. Whether a movie will be a hit or not hit, that is a word, that is a categorization, right? So Khalid says they are all predictions, but they are all independent of each other. Khalid, I was trying to ask that do all they lie in the same type? So the answer is no, because as I was explaining, some predictions give us the numbers, some give us the categories. So depending about what we are predicting, the difference is very important to understand. And where this difference comes from, that is where supervised learning starts making sense. So
Hello, everyone. Again, I'm back with you all, right? So there is a problem. It's a technical problem. You all can understand that we can face these types of problem eventually in the electronic devices, right? No worries. So we'll back to our question again. So what do you just tell me about some different examples rather than of email spam detection for that supervised machine learning? Yeah, I'm here. You can see me now, right? Just tell me some of the examples. Okay, I'm looking over the chats right now. Okay. Yeah, you can ask Himanshi. Music prediction on Spotify based on current and previous listening experience. Yeah, agreed. Pass fail prediction. Okay, that's totally correct. Anyone else? Yeah, Himanshi, you can ask your question as well. If anyone else is also having the question, you can ask. Till yet, I'm looking over the chat box. Okay. Okay, I got the Himanshi's message. It totally depends on you, Himanshi, that how you are working and how long you will take the time for the completion of this specific, right? Specifically modules. So it's totally depends on you, right? Anyone else want to ask something? Okay, okay, Manchi, no worries. Yeah. Okay, she's back again. Okay,
Thank you.
you can take over. Okay.
So, again, back to my point. Today, I don't know why my laptop is giving me so much of problem. So, let me come back to the same concept what we were discussing. So the thing is, I was trying to explain ki behind these predictions, what is the role playing? That is the supervised learning, right? So one of the example which is on your screen, that when you apply for a loan or a credit card, the bank quickly or in hours decides whether to approve it or reject it, right? So what do you think? A human is sitting at the back of the bank and approving these applications? Yes or no? What do you think? Do you think a human is sitting behind and approving or rejecting the applications? You can use the chat. Himanshi says, no, ma'am. So what? How we are getting approvals and rejections on our loan applications, on our credit card applications? What do you think? Okay, Khalid says trained algorithms. Right. So basically, Prinka also says code that implemented. Okay. So sort of we can see that there is no human. In small banks, we can assume that humans can manually see the applications. But what about the big banks? There, a human cannot sit and approve or reject the applications, right? So we have a system which is deciding on behalf of the human because thousands of applications are coming daily, right? So what input we are giving to it? We are giving income, age, credit card, their employment type, or their past repayment history, right? So these are the parameters which we are giving to the machine, and we are getting the result either approved or rejected, right? So my major question is, how does the machine combining all this information, or is it just fixed rules, as you mentioned, code that implemented? So what do you think? Is it the fixed rules or a fixed code which is implemented, or it is learning by the data we are giving? What do you think? Is it learning from the data which we are giving, from the past data, or there are some fixed rules? Learn from the data set. Learning. Anand says learning. Okay. Khalid says learning dynamically using data. Yeah, exactly. So what we are doing means thoda logically socho. Agar if we have two people who apply, one with a stable income and good credit score and another with irregular income and missed payments, so should both get the same decisions? Obviously not, right? Because so something intelligent is happening at the back end behind the scenes, and today we will be uncovering that how they are deciding at the back end. So we have another example, which is you have seen the applications of machine learning in the previous session, right? So this was one of the application that was the medical healthcare. So if you go for any testing in hospitals, in diagnosis centers, or in where the blood sugar is checked, so what you get? You, for every checking, for every diagnosis, you get a report wherein you get a prediction or verdict also written that uh, you are a diabetic patient or you are not a diabetic patient. Your cholesterol level is high or your cholesterol level is fine, right? You are having a cancer or you are not having a cancer. You are having a thyroid or you are not having a thyroid, right? So in every report which is generated by a machine also, we get a verdict on it, right? So how machines are learning, how machines are uh, deciding that someone is at high risk? It's obviously it's not just a guess, right? So it must have seen thousands of past medical records, their age, blood reports, sugar levels, blood pressures, medical history. And if a machine studies patterns from these thousands of past patients, it will start recognizing the risk patterns, right? But again, who teaches the machine what is high risk and what is low risk? मशीन खुद से तो इंटेलिजेंट नहीं होती, right? Someone trains it, and today, who trains it, how training is done? So we are bringing the concept of supervised learning into play, that how they are trained, right? So supervised learning name से क्या पता लग रहा है आपको? As we discussed, that learning with guidance, right? Like a teacher give correct answers. If I show a student math question and the correct answer, over time students learn the patterns, right? So machine learning works similarly. Like during training, we give input and output, and which we call it as labeled examples, which you mentioned, right? And the model studies the patterns between input and output. And once it is trained, it can predict for the new unseen data. बस इतना simple सा concept है. Now, if we move forward, that as we discussed, that learning with the guidance, like a teacher giving the correct answers, we train with labeled data and we use it for prediction. So let's not take much time on this. So let's move on to the loan approval prediction example of supervised learning. Why this is the best example? Because that is what we see around most of the times, that when machine learns from correct data. Now here we give the input applicants data. There is label training examples which is already given, that in which type of data loan should be approved and in which kind of data loan should be denied. Based on that, approved or denied is done, right? So here also, system have learned from the past borrower data, and it is then same rules, same pattern, same learning is applied on the new applicants data for deciding to approve it or to reject it, right? So let's move on to this. So tell me, you all tell me, that if I ask you, you have to approve a loan for me, and this is my data, this is my salary, this is my age, this is my city, and this is my previous loan default, this is my favorite color, this is my Instagram followers. So I want you to tell which parameters you will take into consideration to decide whether to approve the loan or reject the loan. From these parameters, इनमें से कौन सी parameters, कौन से data को आप consider करोगे to decide whether to approve or to reject? Okay, Khalid says age, salary, previous default. Pratham says 1, 2, 3, 4. Okay. 1, 2, 3, 4 means salary, age, city, previous loan default. Okay. Priyanka says salary. Okay, so Priyanka will only consider one parameter, that is salary. Anand says salary, age, previous loan, 3. Okay. Salary, Komal says, Kalyani says salary, age. Shruti says salary and previous loan default. Okay, so most of you mentioned it correctly. We would consider, or any person would consider, salary, age, previous loan default, and in some cases, city also, right? But not necessary. But we won't consider favorite color and Instagram followers. Why? Why you didn't consider favorite color and Instagram followers? What is the reason for it? Irrelevant, Pratham says. Rakshita, first 4. Okay. Khalid says outlier, they are not necessary to the data set and will act as noise. Great technical terms used, Khalid. Not relates to the form requirement. Right, Himanshi? So basically, for the purpose we are trying to solve, the favorite color and the Instagram followers is of no sense, right? So we have not used it. So let's move. So for this, we have the next concept, that what are the ingredients of supervised learning? So we have 3 ingredients in supervised learning. First is the features. Features is what we are taking into consideration. Here, our features was salary, age, previous loan default. Means what input you are giving to the machine. आप क्या input दे रहे हो for your prediction, that is your features, right? The second thing is your label. What is label? What output you were getting here? In this example, what was the output? Tell me the output. In this example, what was the output? We were trying to figure out or predict. Himanshi says loan approval. Loan to be granted or not, Khalid says. Sakshi says approval loan. Approval loan in this case. I was asking what was the output. Output means, as Khalid says, to approve the loan or not. We can say approved or rejected, right? That was our output. So what is basically label? Label is what output we are getting or the answer we want. If we are doing a loan prediction, our approved or rejected will be the output. If we are considering, we are figuring out a stock price prediction, so price will be our output. If we are checking a student will pass or fail, then pass or fail will be our output, and this output in the technical terms is called as label, right? So clear what are features? Features is the input we give, label is the output we get. Clear? If this is clear, mention clear in the chat, then we will move forward. Clear, Sakshi says clear. Khalid says yes, ma'am. Okay, great. So then we have third thing. Third thing is algorithm. Algorithm means what method we are applying to get something. For example, if I want to add two numbers, so my two numbers would be my features, my addition would be my algorithm, and whatever after adding whatever value I'm getting, that would be my output, right? 5 plus 2 is equal to 7. So 7 is my output, plus is my algorithm, and 5 and 2 is my input. So algorithm is any method we are applying to the features or to the input to get the output. So these were the three main concepts of supervised learning. Let's move on to the next. So we will see one by one why these ingredients matter. So why features matter? What do you think? So here you can see we only took salary, age, previous loan default. What if I would have used favorite color and Instagram followers also? How would it have affected? वो effect कैसे करता मेरी prediction? What do you think? How it would have affected? Any idea? If I would have taken, okay, I'm getting answers. If I have would have taken bad impact and rejection, okay, right, Himanshi. Okay, so if I would have taken this irrelevant features, automatically I would have got the less accurate results. Because whenever we are building a model, whenever we are building a machine, what is our main aim? To get the best accurate model, to get the best accurate result for us or the prediction for us. So if we will use these features which is not relevant, automatically we will get right, Pratham, we will get low quality output. So here features are very important because good features is automatically equal to good prediction and bad features is equal to bad prediction. As we can say, garbage in is equal to garbage out. So now we can see there are two types of supervised learning as we saw here. Let's relate to this. Here you can see what are labels, the output. Now, as we discussed, we have two types. We have different types of outputs. One can be numerical. Numerical means our price prediction, stock price prediction, temperature prediction of some place, or what else? Instagram followers of a particular person. Right, that is the numerical prediction. Right, house price prediction. So that is one type of prediction, one type of output we get. Second type we have is email is a spam or not, a student will pass or fail, a loan will be approved or not. That is yes and no, right? That is category data. That is second type of data. So based on what output we get, we have two types of supervised learning. One is regression, that is in which we get the output as number, continuous. And second is classification, in which we get the output as category. Disease, yes or no, diabetic or non-diabetic. These are our categorical class data, right? Now, my question is from you all, that is predicting a blood sugar level a regression or a classification problem? What do you think? Is predicting a blood sugar level a regression or a classification problem? Himanshi says regression. Others? Anand says regression. Pratham says regression. Okay, so I'm getting input from you, answers from you as regression. That is correct, because that is we are detecting a sugar level. Okay. Now, if I am asking you, predicting if a person is diabetic or not, is it a regression or a classification problem? If a person is diabetic or not, it is a regression or a classification problem. Himanshi says classification, Sakshi says classification, Pratham says classification, Khalid says classification, right? So when we are judging diabetic, non-diabetic, now we have category. So that is classification. In blood sugar level, that was the number. So that was regression. So great. I can see you have understood. Let's move on to the third ingredient of supervised learning, that was algorithms, right? So we have four types of algorithms with us. One is linear regression, then we have logistic, then we have KNN, then we have decision tree. So we will move one by one with every algorithm and see how every algorithm is used and which method to be used for which purpose. So first one is a linear regression algorithm. Now linear regression is very simple. What do you mean by linear? In English terms, if I ask you what is linear, what do you understand by linear? Let me see the chat. Sakshi says equation, right? Linear equation. Himanshi says straight line, which works as a straight line of data. Khalid says static. Priyanka says, okay, what else? Let me see other replies also. Static, linear. Okay. So a lot of you are saying straight, right? So you are somewhat right. Linear regression is we are try to build or draw a straight line by finding the relationships. And by this straight line itself, we try to predict the numbers. How? Let's see it. So if I tell you, you tell me, can we predict the Instagram followers? Everyone uses Instagram, yes or no? Or LinkedIn? You might be using Instagram, LinkedIn, or both. Yes or no? Okay, Priyanka says yes. Himanshi says yes. Aditya says no. We can't. Okay, Aditya. So you are not on LinkedIn. You are not on Instagram. Okay, great. Anti-social. You are anti-social, Aditya. Okay. So Shruti says both. Okay. So a lot of you are using either of one. So tell me, can we predict the Instagram followers or the LinkedIn followers? Can you predict it? Okay, Aditya says, I mean to say we can't predict. Okay, got it, Aditya. We can't predict, Aditya says. Himanshi says, yes, we can predict. Komal says, no. No. Sakshi says, no. Okay. So if I give you this data, which is there on the screen, that if a person is having one post per week, they have gained 50 followers. If they were having three posts per week, they have gained 150 followers. If five posts, 250 followers. This is the data I have given you, right? Now, let Plot this data on a graph. This is what a graph is. Points. These blue points are what we have the data with. Now, if I ask you that if I post four, I post four times in a week, per week, how many followers I can have? What prediction you will give? We have the data for one, we have the data for three, we have the data for five posts per week. What about? Okay, Mohammed says 200. Linear graph. Sakshi says 200. Okay, Sharnu have given me. Vivo says 200. Again, Vivo, please join from the next class from your name so that we can interact. Anand says 200. Pratham says depends. Okay. Himanshi, I have asked that if I post uh four four posts if I upload per week on Instagram or on LinkedIn, how many followers by the data shown on the screen you can predict I will get based on the posts I am uploading. Manchi says 200. Okay, so most of you mentions 200. But so how did you guess 200? How did you guess 200? In your brain or by seeing this graph, some of you must have seen the graph, some of you through your brain itself, through imagination, you might have drawn a straight line from the data which is given on the screen, right? And when we draw this, we can see that if I post 4, it is around 200 followers get, right? So, so you basically made a linear equation itself, linear line itself. Now let's see through a visualization, scan this QR code, we will see how actually linear regression works. Scan this QR code. Once done, mention done in the chat. Let me also open it. Once scanned, mention done in the chat. Okay, Khalid says done. Others, hurry up. Scan the QR code fast. If you want, I will share the link also in the chat. You can open through the link as well. Himanshi says done. Anand says done. Okay, great. So let's see. Now, when you opened it, it was plotting the points. Now, these are the random data points, right? So these are the points as you have seen here on the screen. From the data we have plotted these points. Similarly, there are some data which is uploaded on the site and that is plotted through the points, right? Now, as you can see above, it is the absolute error. Now, what is the error? Error is how much there are chances that our prediction is correct or wrong. So we are getting 84% accuracy. Means 84% it is assumed that our prediction will be correct when we will use this model which is shown here, right? So let's see if I have some new. Now this is your straight line. Let me give you one answer. If I put one point here, this is my new data point. You can see on the screen first, then you will try. First you can see on the screen, then you can try on your own. When I have put this point here, you can see your accuracy increased. Now if I plot this point here, your accuracy decreased. If I plot this point here, again, now if I plot a point here, your accuracy decreased to a huge level. Now if I plot a point here, again to 26%, very less accuracy, right? Now, see, your accuracy will start increasing. Now, what is this actually? Let me explain you. So these black points are basically the data we have, right? And now what we do is in the real life, our data never lies in the straight line. It is always a messy data. For example, if I am trying to predict how much weight loss a person is doing. So that cannot be fixed. One week a person would lose more weight, one week they would gain some weight. So that cannot be a straight line in the real world scenario, right? So how we apply a straight line is, we sketch or we draw a straight line in a manner that it passes through maximum points. So that, and that straight line, this straight line, black line, is called as the best fit line. What this is called as the best fit line. Now why this accuracy is changing based on the points I am plotting is that this red line which you can see, this is basically the error. Error means how much difference is there between my actual value and predicted value. For example, if you try to predict the price of your own home, right? So you built a model based on the price of the houses in your area. You built a model, and based on the past data of that area, and when you try to predict, you get, for example, you get 250 25 lakhs for your flat, for example, right? But your actual price is 30 lakhs. So what is the difference? Error rate is 5 lakhs error, right? So the difference between your actual value and your predicted value is the error. So you can see here, this is basically the absolute error red line which you can see. So this is my actual point. This is my prediction line. This black line is the prediction line. So if I refresh, I will show you one more thing. Let me refresh it. See, it is plotting some random data points and making the best fit line, which is passing through the maximum points. Once done, now if I plot any point which is near to this best fit line, the accuracy will increase because the difference is very less. आपकी actual और predicted value के बीच में difference बहुत कम है, तो automatically error क्या हो जाएगा, कम हो जाएगा. But if I plot some data which is very far away from the prediction, कि prediction मेरी थी 1 CR की, but actual value मेरी क्या है 10 lakhs is 10 lakh. Very great difference it is, right? तो आपका model automatically क्या हो जाएगा, less accurate. For example, if I plot a point here, see, sudden accuracy shifted to very less value, right? Now, if I will start plotting the point near to this, the accuracy will start increasing little by little, right? So this is what linear regression is. And in linear regression, our main purpose, what is our main purpose in linear regression? Our main purpose is to get this best fit line, so that our error is minimum and our accuracy is maximum. That is the main purpose of our linear regression. So did you get how linear regression is performing? Mention clear, or you get it in the chat if you are understanding or you are with me. Okay, Pratham says gotcha, Anand says clear, Sakshi says clear. So we usually see every model is applied depending upon what data we are handling and what predictions we are trying to make. So based on that, we decide which model to choose. That you will see by the end of the class also. Now, this linear regression is usually used when we have something numerical to answer, like stock price, house price. That is regression, right? And linear means which is near to a straight line. Not exactly straight line, but somewhat near to straight line data, right? Now, tell me one thing. Will data always be perfectly straight? What do you think? In real world, data would perfectly be straight or no? No, no, no. Yes, exactly, because in real world, our data is always messy. So your points won't sit perfectly on one straight line. So our aim for linear regression would be, see, this can be asked in interviews also. What is the aim of linear regression, or what is the agenda for creating a linear regression model? It is to get the best possible line that minimizes your error or gives you the best accuracy? That is the very simple answer we are trying to solve through linear regression. Now let's move forward. As we learned for linear regression, let's move on to the next. In linear regression, we were predicting number. But if I want to predict a loan to be approved or not, a email is spam or not, a person is diabetic or not, I cannot use linear regression for it because as I mentioned, it is used for numerical data, right? So when it is a category, we use other models like logistic regression. Now, what do you think? Logistic regression, as I mentioned, it is used for labeled categorical data and it gives the answers, helps us in the prediction of yes, no, or diabetic, non-diabetic, spam, not spam. So what do you think? Does it directly give yes or no as the output? What do you think? Does logistic regression gives us the output as yes or no directly or something else? What do you think? Yes. Okay, Pratham says it does. It does what it does. That is what I'm asking. Okay. So let's leave the guessing part. I will tell you that it gives us the probability. It does not give you yes or no. How it gives you the probability? Let's see. So tell me in the chat. There are three customers in front of you on the screen, customer A, B, and C, with the data of income, EMI, and the past defaults. You have to tell me that which customer looks at the default risk for loan repayment. आप किसको लोन दे दोगे और किसको नहीं दोगे? Customer A, B, C में से if someone asks you for the loan based on the data which is mentioned, for whom you won't give the loan, किसको आप लोन नहीं दोगे and why? Kalyani says A. Why A? B. Pratham says. Himanshi says customer A. Why? We won't give to B. Khalid says we won't give to B. Tejaswini says B. Okay, everyone tell me why. If you say A, why? If you say B, why? One line answer. B because he has more EMI and past defaults. Khalid says B has two past defaults, low income. Right. So okay, based on your thinking, some answered A. I don't know why they have answered A. I want to know that because of past defaults. Himanshi, because of past defaults, if you are answering, it cannot be A because A has no past defaults, zero past defaults, and A is having highest income. So there are much chances that A will repay your loan. A आपको वापस आपका लोन रिपेमेंट कर देगा, right? But what about B and C? B and C. B is having less income and more past defaults. So there are more chances of B of not repaying your loan, right? So in ideal case, we won't give the loan to B, right? So now what if this is our intuition? But what if how machine see it? Machine see it using a model score. If a machine is trained for this, it will give them a score: high risk customers or low risk customers or moderate customers, right? So let's us see here. For example, if this is the probability of the risk we are getting of A, B, and C, and if my bank, for example, have decided if the default probability is less than 0.75, the loan can be approved. If it is greater than 0.75, it would reject the loan. So what you think, whose loan gets rejected by the data presented on the screen? Whose loan gets rejected? Anand says B. Okay. Only B? Only B? Himanshi says B and A. No, okay, it was the previous answer. No, C also. Anand says. Tejasmi says B. Okay, let me clear it out. So, The ones who were saying B, that was correct, because B is the only person whose probability of risk is more than 0.75. 0.55 is less than 0.75 and 15 is also less than 0.75. तो हमारा सबसे ज्यादा रिस्क 0.75 से ज्यादा किसका है? सिर्फ बी का. सो लोन किसका रिजेक्ट हो जाएगा? बी का रिजेक्ट हो जाएगा एंड ए एंड सी विल गेट द लोन. नाउ इफ आई मूव टू द सेकंड सिनेरियो, नाउ माय प्रोबेबिलिटी हैज चेंज्ड, माय दिस वैल्यू हैज चेंज्ड. अब मेरे बैंक ने क्या डिसाइड किया? Not 0.75. The people who are at risk of greater than 0.5, that is 50%, will get their loans rejected. Now, in this case, किसका loan reject होगा? Whose loan will be rejected? What do you think? Whose loan will be rejected? Now, in this scenario, Anand says B and C. Okay. Sakshi says B and C. Khalid says B and C. Komal says B and C. Okay, Tejaswini also says B and C, right. So B and C is greater than 0.5. So both of their loans will get rejected and A's loan would be approved. Now tell me one thing. What is this value? 0.5, 0.75. What is this? What is this value? 0.75 and 0.5. What is this value? How a bank decides this value? How a bank decides this value? What do you think? So this value is basically based on the bank to bank or based on the economy in our country, that is decided with the bank or the policies. Pratham says CIBIL score. CIBIL score is for the appliers part. प्रथम जो अप्लाई कर रहा है दैट इज द सिबिल स्कोर. बट बैंक सिबिल स्कोर सेट नहीं करती, वो सिबिल स्कोर का क्राइटेरिया सेट करती है. यू आर राइट. But here we are not talking about CIBIL score, we are talking about the threshold. Threshold, what I mean to say is, if you're in your colleges, does it happen that you should have 80% attendance to sit in the exams? Is that happened with anyone? You have to complete 75% or 80% attendance to sit in the exams. It happens. So that 80% is the criteria which you have to fulfill, that value you have to pass by to sit in the exam, right? So that value which is fixed by the colleges, universities, that is the threshold value for you to sit in the exam. Similarly, here the 0.5 and 0.75 was the threshold value. If your value is above this threshold value, you get into the approved category, otherwise you get into the rejected category, right? Now tell me one thing. If two banks use the same data, means if I go in two different banks and I apply for a loan, so what do you think? Can they give different decisions? What do you think? Can they give different decisions? If I go in two different banks, apply for a loan, can I get two different decisions? Yes or no? Okay, let me see the chart. Yes, why? Pratham, why I can get? Sakshi, why? Sakshi says yes. Varies state bank to national bank. Okay. Mohammed says state bank to national bank. Anand says no. Okay. Pratham says goodwill. Pratham, it's not a goodwill. Means bank is not working on goodwills. They are working on some policies. They are working on some rules. Right? Okay. So yes, we can get different decisions because every bank has different threshold values. Every bank will have different criteria. For example, if PNB has set the CIBIL score to be mandatory as 650, it is not mandatory SBI is having the same score. Maybe SBI has set it to 700, right? So that threshold value is very important and that can differ based on the problem we are looking at, based on the university. Some universities have 75% attendance as compulsory, some might have 80%, right? So this is what your logistic regression is, what we solved right now in front of you, that based on the threshold value, you lie in the first category or in the second category. That is decided through logistic regression. That is how logistic regression works. If I have to decide if an email is a spam or not spam, so I will check what is the probability score of the email to be spam, or what is the probability score of that email to be not spam. Based on that criteria I will decide, and based on my threshold value I will decide हम उसको spam में भेजे या inbox में रखें. Clear? Understood? Are you all with me? Mention yes in the chat if yes. Anand says yes. Himanshu says yes. Okay, Khalid says yes. Okay, a lot of yeses in the chat. Let's move to the third algorithm. So we have covered two algorithms as of now, linear logistic. Let's move on to the third one, KNN. KNN is K nearest neighbor. So now what is KNN basically? Look at the my pointer. You can see the pointer, my mouse on the screen. So see, look at this. I'm not going on to the theory part. Just move on to the what image is shown on the screen. Here we have few pointers, which is the data of the past students. Then we have in red dots, we have the data of the failed students, right, with us already. Now, if a new student comes in, we have to predict it should lie into the pass or the fail category. How you will decide? How we will decide? One way is by the marks, right? Other ways we don't know the marks, right? So what we will do, how we see if you go at some new place, in a new session, in a new class, in a new university, in a new school, everybody judges you by your company, right? If you are sitting with the sincere students or the front benches, or you are sitting with the back benches, or you are sitting with the students who make mischiefs in the class, who are not sincere, so you, irrespective you are sincere or not, you are categorized into that category automatically based on what neighbors you have, what friends you have, right? Does that happen with everyone? That based on what friends you have, based on what neighbors you have, automatically you are categorized into that group itself, that this student will be a not a sincere student, he or she is having not sincere friends, right? So I can see yes, yes in the chat. So it happens with everyone, right? So we will see, let's see visually how KNN works. So KNN works in the similar manner. Now, to be clear, our logistic regression was working on probability. Remember the word probability for it. Now KNN is working on the similarity, कि आपके data points कितने similar है. ठीक है? Now let's see it visually. Scan this QR code and we will see it by a visualizer how our KNN works. Khalid says it's a saying too, a person is known by their company, right, Khalid? So that is a saying also, and in journal also, that Pratham says I'm a good neighbor. Great if you are. One scan mentioned done in the chat. Let me share the link also as some of you are asking for. So I have given the link in the chat. You can open from that also. Okay. A lot of you are saying done. Let's see. Now, when you scroll a little, turn on this show decision boundary. There is one thing written, show decision boundary. Turn on this. Once you do this, you will see a slight boundary is shown on your screen. Where we have blue dots, we have red dots, right? Now, if I plot any point here, for example, if I give a new point here, just click. What I am getting? This new point is categorized into the blue group. How? How? Because the nearest point to this new data point was the blue group data points. So automatically वो किस group में चला गया? ब्लू में. नाउ इफ आई हैव अ न्यू डेटा पॉइंट विच इज नियर टू द रेड, तो ये ऑटोमेटिकली किस में चला गया? रेड ग्रुप में, राइट? सो इफ आई प्लॉट अ पॉइंट इन बिटवीन, अगेन रेड. ठीक है. सो दिस इज हाउ KNN वर्क्स. इट सीज द नेबर्स. और वो नेबर्स कैसे देखता है? वो डिस्टेंस कैलकुलेट करता है बिटवीन द नियरेस्ट डेटा पॉइंट्स. अब द क्वेश्चन इज हाउ मेनी पॉइंट्स टू कंसीडर. इसने 3 ही पॉइंट्स क्यों कंसीडर करे? व्हाई डिड इट ओनली कंसीडर 3 पॉइंट्स, नॉट 4, नॉट 5? इसने ये पॉइंट्स क्यों नहीं कंसीडर करे? राइट, दिस इज द मेजर क्वेश्चन वी हैव. सो there is a parameter which we set while we build a KNN visualizer, that is called as the K value. So if we change the value, now you can see it, the K value was set to 3. So it was only looking at the 3 neighbors. So K value is similar to the best friends, right? If in a class I said that you are judged by your company, so you're not judged by the whole class you are sitting with. You are judged by only your best friends who are close to you, right? So K value is similar to that. If I increase the K value to 5, now see. So it is looking at the 5 nearest data points and then giving you the prediction. Now if I plot here, so now see, this point which I have plotted just now, it is lying 80% into the blue and some one point is nearest to red also. So this accuracy 80% is decreased because it is having some nearest data points into the red category also, right? So this is how KNN works. It is used to classify or do the prediction based on your nearest data points. Done? So you can try it. Just you can try with the simple binary. Then you can change the data set from here, multi-class, different data sets are there, and then you can try later on. If you have done this much, mention done in the chat so that we can proceed. Okay, Himanshi says done, ma'am. Anand says done. Khalid says done. Okay, Sakshi says done. Okay, let's move further. So, okay, so here there is one data given. Tell me if based on the hours studied, based on the marks, a result is given, pass or fail. What do you think? This new student, if he or she studied 6.5 hours and the marks is 43, the new student will pass or fail. What do you think? Look at the data and tell me if the new student will pass or fail. What do you think? The marks is 43 and hours studied is 6.5. Mohammed says fail. Okay. Pratham says pass. Okay. Anand says fail. Komal says fail. Okay, let's check. So these are the data points. If I plot those points, the data which I was having on the graph, and if I check the distance of this new point with the already existing data, it is more close. See, the distance is more close to the blue ones. So the prediction done would be pass, not fail. That is how you randomly guessed it, right? Himanshi says pass. I can see a lot of mix of answers, fail and pass. So you have randomly guessed it. But how KNN works, it sees the distance based on the graph and it has given the prediction as pass because it is nearest to the C and B, the students who are already in the pass category, right? Oh, Khalid has realized, oh sorry, yes, okay. Okay, no worries. So it is not your, it's good that you are answering either correct or incorrect, doesn't matter. Okay, so this was your KNN. So understood? Linear regression, logistic regression, KNN. If yes, mention yes in the chat. Then we will move on to the further algorithms, that is our decision tree and random forest, and that are very interesting algorithms, I would say. Himanshi says yes. Khalid says yes. Okay, great. So let's do a small hands-on with this. Then, because we have done a lot of theory, let's do a small hands-on. What this is, let me tell you. You can scan this, or I am providing you the link. Let me show the link. Give me a minute. Okay. So I have shared the link. Now this is an application. You can download it for the Windows. It works mostly in the Windows for now. In Mac OS also it can work. So you can download it. By the time I'm showing a basic example of how you can build the model without code, by the time you can install it, because we would be building again one model at the end of the session in this application only. So you can start downloading part. By the time, let me open it. You can see my screen the for now. Let me reshare my screen. Give me a minute. Okay. So everyone, mention the visible in the chat if my screen is visible. You can see a white screen. Mohammed Khalid says, I'm on mobile. No worries. You can see, I'm showing you the demo. You can practice it later on. Save the links with you. Okay, everyone has confirmed visible. Let's see. So see, this is our application where we have multiple options. Without coding, we can build the models. Without coding, we can train the data sets with n number of, you can say, options to explore. So first thing on the left side, you can see is the data, that we can have multiple types of data. CSV, data set. CSV is comma separated files. If I have the data set downloaded from any other site, I can upload it here. If I have some file, I can upload it through this operation. And if I want to use some inbuilt data, which we will be using right now, that is the data set. Then we have transform. Transform is जो हमने पिछले सेशन में you have studied it with Gaurav, that transform is जब हम डेटा को थोड़ा क्लीन करते हैं, that or we make the data in a state that we can work on it, that is transform. Or train and test. Gaurav has taught you that we split the data into two parts, training and testing, right? So one data is used for training our machine, other data is used for testing our machine, right? So all those operations would be done using transform, these functions under transform. Then we have, if we want to draw graphs, we can use from here. If we want to draw model, you can use from here. So let's build a basic logistic regression and KNN. So you just have to drag and drop, or you can double click also, right? Then second thing, first I have taken data set because I would be using one inbuilt data set. Then I have taken data table, right? So I'm only dragging and dropping. Data table is used when I want to see the data set in the table format. That is data table. Then I will use select columns from the transform tab. As I said, keep your notebook and pen ready so you can note down what I am doing so that you can also do it when you have downloaded the app. So then we have select column. Select columns is we would be deciding the train test split. Then we will build a logistic regression. Let's have logistic regression, and we will have one KNN. Okay, we have KNN. Himanshi says, can you repeat? Okay, so first I'm repeating. First we have taken a data set from the data tab, right? Then I have taken a data table. Then I have dragged and dropped the select columns from the transform so that I can select which columns to train my model on. क्योंकि other columns you have seen, some features are irrelevant, right? So we can do that in the select columns. Then I am selecting the model. I have selected two models, logistic regression and KNN, जो भी हमने पढ़ा. Then I would use a prediction. Let's use the prediction here, test and score, right? That we would be testing the model and doing the scoring part. Clear, Himanshi, till here? Everyone, it's clear till here what we have done? Mention yes in the chat if it's clear. Okay, I can see. Sharnu, yes. Himanshi, yes. Priyanka, yes. Khalid, yes. Okay, making a basic supervised learning model. Yes, Khalid, you are right. So now how to select the data in this? How to select the data in this? I will double click on the data set. You can see I have n number of data sets which are there in this. I have numerical also, I have categorical also, right? So let's suppose you can use Titanic or you can use zoo data, any data which you want. Let's use zoo data. So it is selected. Then now how to connect this every, you can say every item we have selected. How to connect? You just have to drag and drop the end of the data set to the start of the data table, then the end of the data table to the start of select columns. Similarly, end of the select columns to the start of our models, and similarly to the test and score. So you just have to drag and drop, it will be automatically connected. Let me close this. Okay. So now let's see the data first. I will double click on data table. You can see this is our data, which we have selected the zoo data, in which we are categorizing a particular, you can say, animal is a mammal, fish, or a bird, or an invertebrate. In which category this based on the features this particular animal is belonging to, right? So we have tail, legs, feathers, hair, every data. Now you can see there is a mention here selected data to data. Now if I double click on it, you can select if you want to transfer selected data to the data, or you want to transfer the whole data. So if I write whole data means your whole data will be passed on to the next. Okay. Now at the bottom you can see a play pause button. If you click on it, now your model is completed. This was the only part to build a model. See how easy it is. We have not written any code. We have not written anything. So if I double click on test and score, you can see our testing and prediction is done. You need not to worry. What is this AUC, CA, F1, PREC? You don't have to worry this. This we will study in the further sessions. These are the different parameters which is used to check the accuracy. You just have to check CA for now. CA for now, you can check. So we have 82% with KNN and we have logistic regression 97% accuracy. Means for this particular data, our best model is between both is the logistic regression. So in real life, what we do is we build different algorithms on a single data, and which algorithm gives us the best accuracy, we use that for further for our predictions. So here our best result was given by logistic regression, right? So this is how we can build a model. Now if you want, you can explore it more. Now your work is to try taking a numerical data and try building a linear regression. See, we have here linear regression also. As you can see in the model section, where's the model section? Here there is linear regression also. So I have shown you building logistic and KNN. Your work is to try building a linear regression model with the same thing, right? So let's move on to our back to our PDF. Give me a minute. Let me reshare the screen again. Okay. So okay, so quick, I would ask you few questions. You have to guess the algorithm. You have to think like an AI system. So tell me. So we discussed two things: logistic regression, probability-based systems, and KNN, similarity-based systems. So first scenario, Netflix recommendation is a probability-based or a similarity-based? What do you think? Netflix recommendations is a probability-based or a similarity-based? Khalid, keep your questions with you. I would take last 5 minutes. I would take all your queries. So note down your queries. We would take at the end. Kalyani says similarity based. Sakshi says similarity based. Himanshi says similarity based. Okay, let's see. So you are right, it is similarity based. We check that what content you are watching is similar to which group category, right? Now let's second scenario, spam detection. Is it a probability based or similarity based? What do you think? Is it a similarity based or probability based? Spam detection. Okay, let me see the responses. Himanshi says probability based. Kalyani says probability based. Okay, Shruti says probability based. Sakshi says, okay, most of you are saying probability based. Let's see, right? As I mentioned while teaching logistic also, that we check the threshold probability. If it is a spam probability, if it is less than a threshold, it is in the inbox. If it is greater than the threshold, it goes into our spam folder. Next, our face unlock. We have a face unlock option in your PCs, in your laptops, in your mobile phones. Is it a probability based or similarity based? What do you think? Similarity based, similarity based. Okay, so let's see. Right, it is a similarity based that we have already one face stored, feature stored while we were setting up our lock, and our current face is compared to the already saved face, and the match is done as per the patterns, right? So let's move on to the next concept. So we have understood the three algorithms. We are moving on to the last one. So if I ask you, like, if tomorrow is a exam, right? And tonight we have a India versus Pakistan match, what you will do? You will study, watch match, or watch match with the open book. What you will do? Priyanka says, see, watch match with the open book. See, oh, a lot of people with C. C people are very dangerous. They won't leave the match. They would study also. Most of you are C. Imanshi says C. All cricket lovers. C. Okay, so all of you are belonging to the same category, like to the C category. We would watch the match with open book, and I can see few people who have chosen A, that is they would study, right? So what you have done basically here, you have created a decision based on different factors as in your exam importance, your match importance, your interest in cricket, your confidence level in your exam, your internal marks. Sometimes we feel we have enough internal marks. We need not to study more for this. If we study limited also, we will score good, right? So we did feature selection. We selected some features based on without knowing, and we took one decision randomly, right? Okay, so tell me one thing. How do you usually make important decisions? Do you always make decisions alone, or you ask your friends, or you ask your family, or Google it? How you usually make decisions in your life? Alone, with your friends, you ask family, or you Google? Khalid says on your own. Okay, self-independent. Others, how you make decisions? Okay, Himanshi says with friends and alone. Sakshi says, ask family. Okay. So you can see we have a mix of people. Uh, and instead of family, instead of friends, instead of people, if we have a model with us who can help us in making decisions in our day-to-day activities, wouldn't that be too great, right? So let's move on to the next thing. Why decisions are actually made? Decisions are banate kyun hai? Why decisions are actually made? uh, in our whole day routine, we make different decisions, either to wake up or snooze the alarm, to eat healthy or to eat junk, to study or scroll the Instagram, to uh, play outside or to stay indoor. So why do we even make decisions? Because we want best outcome for us, right? And best outcome depends upon the information we have, right? Now, This is how we think. But what about machines? What do you think? What about machines? How machines decide? So machines basically have means it would be very difficult if machines would structure this type of thinking as we are doing, asking five friends, asking family, or just flipping a coin to decide whether to go for a movie or not. Right? If machine would do the same thing, it would be very difficult to get onto a decision. Right? So how machines do or how machine take decisions without any confusions, how they turn confusions into clear paths, that is where decision tree comes into picture, right? That is our fourth algorithm. So have you ever felt confused about anything, weekend plan, or should I study, should I reply to someone, should I buy a phone or not? Tell me one thing which you were confused about in the last 2 to 3 days. One thing which you were confused about in last 1 to 2 days. Anything. It could be anything. What was that thing which you were confused about? Himanshi says study routine. Okay. Others. Everyone was clear on everything. Okay. Tejaswini says study routine. Okay. Lot of people with study routine confusion. Sakshi about exam study. Okay. So life is means we in our life is basically a decision, but without even any manual, right? So let's see. For example, if I have to choose in between, like what to decide, help me decide what to do this weekend, or help me decide which technical skill to learn, or plan a trip for me, or whether to buy a phone or not. You can pick any of this prompt, and after this, scan this QR code and will share the link of this also. Who all can scan, they can scan. Otherwise, I'm sharing the link also. Okay, I have shared a link. Now, now see, this is a AI powered interactive decision tree wherein if you write a prompt, what you want to do, and you click on generate. For example, from here, if I pick up one prompt, help me choose which tech skill to learn. And if I paste it here and generate, it would take some time to generate. It would process your data, it would analyze data, it will generate a proper decision and give you the output. So you can copy paste the prompt, and by the time it is generating, see on the screen, I have some already generated results for you. So few hours back, I mentioned this prompt to this generator. Help me decide between a buy a phone or a laptop, right? So when I asked this, uh, it created this thing for me. Now first question, it is asking me what is the primary use. Now if I click on this dot, it is asking me three options. It is giving me three options to decide. Work and heavy study. What is the use for me? Communication and social and on the go. Gaming and media consumption. So let's see work and heavy study. Now it is asking me requires heavy software, video editing, 3D coding. So if I click on it, I have two options. Yes, heavy tasks are needed. No, mostly browsing and docs are needed. So let's see heavy tasks. So it is giving me a result by a high-end laptop and giving me the output with the options also which high-end laptops. For example, if I would have chosen second one, it is asking me again next question. I need a ultimate probability portability or not. Means if I need a portable one, I can have a lightweight ultrabook, or if I don't want a portability, I can have mid-range laptop with a standard budget. So see, now what I have a number of questions through which I am getting onto a decision. This is how we also process decisions in our daily life, right? That for deciding whether, for example, I want to decide that whether which new technical skill I should learn. So I would have multiple questions in my mind, and then I would reach to a decision that, okay, let's start with Python, right? This is how we take decisions. Now, let me show you one more example. This is the another example what to do on this weekend I have asked. Now, if I elongate it, it is asking stay in or go out. It is asking me two questions. See how amazing it is. Now, I'm asking stay in. Now, it is asking me to be relaxing or productive. Let's say productive. So, it has given me, sorry. So, it has given me four options: deep clean the house, meal prep, learn a new skill, organize digital files. What if I have chosen go out? Nature and active, social and city. Let's choose social and city. Based on it, I'm getting four again options. So now here, no friend, no family, no person is helping us to make decisions. Our machine is helping us in making the decisions, and very basic decisions, right? So this whole algorithm which you have seen on the screen, this is called as decision tree. Now let's, have you done, have you applied here? See, it has created this also, tech skill selector. Let me show you this also. It is asking me what is the interest of mine: web development, data and AI. Let's choose data and AI. I want to learn machine learning or data analysis, machine learning. So it is telling me either go for TensorFlow or go for PyTorch, right? So it's so amazing. Now let's, have you done? Have you tried? If you have done, let's move on to our PDF and our concept of decision tree. Done. If you are done, mention done in the chat. Anand done. Khalid, yes, ma'am. Okay. So let's move. Sakshi says done. Okay. So let's move. So this is what decision tree is. Now, basically, it is a tree-like structure as you have seen. We have different branches. It comes under your supervised learning, and it, how the split is made based on the conditions. You can see here, it is making the split based on decision. Decision means what you are choosing, either to stay in or go out. So that is a condition based on which it is choosing. So the split is done based on the conditions or the features, logics. Now, what is the anatomy of a decision tree? Now, what is anatomy is, if you see here, let's go on to this. If I close the whole part. So this is my first thing, first question, what to do on the weekend, right? So now decision tree is sort of a inverted tree, and our inverted tree starts with roots, right? Our inverted tree starts with roots. So our first question which we are trying to solve is our root node. What is that called as? Root node. So here my root node is weekend plan. Now, if I elongate, let's close this. We'll go one by one. Okay. Now, these two options which I have, stay in or go out, this is my second step, that is decision node. Decision node क्या होता है? जो हमें decision बनाने में help कर रहा है, right? For example, now this second node is helping me towards the prediction of a decision or to decide what to do. So this is my root node, this is my decision node, and these lines are the branches. हमारे roots और leaves कैसे connect होते हैं? Branches के through, right? And if I elongate it more, now this is again decision node 2, and these are the branches. If I elongate more, now these green ones are your leaf nodes. Leaf nodes are, leaf कहाँ पे होती है? सबसे top पे. Our inverted tree starts from the root and goes to the leaf, right? तो हमारे यहाँ पे root node से start हुआ, हमने different decision बनाए, और हम end में कहाँ पे आए? Leaf node पे. Leaf node वो node होता है wherein we have our decision with us. हमें पता है what decision we have. So here we have 4 decisions with us, right? आगे आपकी branching नहीं हो रही. We are not asking more questions to get to a decision. So उस node को हम क्या बोलते हैं? Leaf node. So this is your anatomy of a decision tree, wherein we are starting with the root node, going to the decision nodes based on different logics. Yes, no, we are coming to a main decision, that is leaf node. Correct? So this was the anatomy of a decision tree. Now, this is a very simple real life example which is shown here. Tell me, which is a root node here? Which is a root node here? Hurry up, tell me in the chat which is a root node here. Okay, Khalid answers, is it cloudy? Okay, others, what do you think? Himanshi says, it is it cloudy? Priyanka says, cloudy. Anand says, is it cloudy? Komal says, is it cloudy? Yeah, right. So, is it cloudy is our root node. Yes and no is our conditions. And is rain expected? Is a leaf node or a decision node? Is rain expected is a decision node or a leaf node? What do you think? Is rain expected is a decision node or a root node? Decision node. It is not note, it is node, N-O-D-E. Decision, Khalid says. Okay, decision. Right, this is a decision node because again it is splitting into two. And this don't carry umbrella is our leaf node, wherein we get to some decision. So this is the whole analogy of your or anatomy of your decision tree, which is very relatable to our thinking when we are taking decision in our real life. So how decision tree basically works? That works, ma'am, yes and no are called branches. Yes, exactly. Yes and no are the logics. It could be threshold also. Greater than 50, it should be yes. Less than 50, it could be no. The connections of the logics is the branches. So you are right. Yes and no are the branches. Conditional branches, you can say. So how decision tree work? They are this we split the data as we do for every model. Then we choose the best feature, means most informative inputs we choose. Then we create the rules, different questions we ask, and then we get to the final decision, that is the leaf node. Okay. So can a machine learning understand without knowing you, without meeting you, without talking to you? Can a machine classify you as a human? What do you think? Can a machine classify you as a human? What do you think? Yes or no? Let me see the chat. Yes, yes, yes. Okay. A lot of persons are saying yes, but how? If the machine is not knowing you, have not met you, without talking to you, how it can classify you? How it can classify you? Tell me fast. Khalid says, because we provided with instructions and data. That is what I am saying. Without giving any data, without knowing, without meeting, the machine cannot know us individually, right? But let me show you one thing. You can scan this QR code, and I'm sharing the link also. Let me share the link. Then I'm showing the QR code. You can scan that. Scan the QR code which is shown on the screen. I've shared the link also in the chat. Once done, mention done in the chat. Once done, mention done in the chat. Everybody has scanned. Open the link. Okay, so what we have here is, it is also a decision tree. And let me show you how it is, what it is doing. Now, it has different questions. Based on that, it will categorize your, you can say, traits and your personality types. What kind of a personality you have as a person. So, are you an introvert or extrovert? It is first question it is asking. Introversion or extroversion? ISTP, ma'am. Right. So, it is, if I choose introversion, okay. So if you hover your cursor here, you can see what intuition, sensing here means. How the words are termed here. So we have one intuition, we have sensing. So okay, I go with sensing. Then I go with thinking or feeling. Let's suppose I go with thinking. Okay, if I go with judgment or I go with perception, I am a person who go with judgment. A judgment means a person who enjoys closure, who have deadlines for their work and take them seriously. So I can go into the trusty category and I have the traits also written. They are dependable, they are trustworthy, they dislike chaos and work on a task until completion. So see, based on the selections I have made, it has given me some personality traits which is similar to what I am, right? So if I go with, let's go with some more. See, for different, it is giving different traits, scientist, author, seller, right? So you can try this and test that how similar personality you have based on the inputs you are giving to the machine. So this is also a decision tree wherein decision tree algorithm is used to identify the personality types of the people, right? So this was your decision tree algorithm. Let's move further. So key advantages are this only, that it is very easy to understand and it takes human like decisions because we also go step by step while we are making a decision, and it is used for flexible applications. I have never mentioned while teaching decision tree that you can use it for classification, you can use it for regression, you can use it for any data, right? So now the next concept, the last concept we have for today is random forest. Now decision tree and random forest more or less is similar. Tree is a single thing, right? But if I have to take any decision or you have to take any decision, what do you think? Three people who are a master of something can give you better answers, or a one person can give you better answer? What do you think? One person or three persons who are a master of something and you are asking for some decision or some uh, answers, who can give you better answers? Okay, I can see. Rakshita says three people, three person. Priyanka says three. Sakshi says three. Right. Because one tree, we have one path, right? We were having single path, right? And if there is a small change, your structure can change completely. But what if we can combine different trees? So when we combine different trees or when we rely on the opinions of many people for making some decision, for example, if I'm ordering some food from Zomato. So I would not check only single review. I would check multiple reviews and then judge if a restaurant is good or bad, right? So similarly, if I want to buy a phone, I would not rely on single person who is tech savvy. I would ask eight different persons and observe what are the common suggestions, because one person can have a good experience with a single mobile phone and another could have a different experience, right? So I would ask multiple people. Now, Khalid says we can ask for multiple people and then take what we deem fit given our exactly, exactly, because decision lies with us, but we can take multiple opinions and whatever is the best decision for us, we take that. This is very similar to how we process things in daily life, right? So that is what random forest is. Random forest is a combination of multiple decision tree. Every decision tree is trained on different data set. Means if I have 100 points, 100 students data, I would train one decision tree with 20 students, I would train another decision tree with another 20, then I would train the third decision tree with another 20, right? So I would have three outputs of something, first, second, third. And what I would do, I would combine the decision of all the three and create one strong model. That would be my random forest, right? So अब combine कैसे करोगे आप? अगर for example my two models are giving me yes, my two models are giving me pass, 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 and my one model is giving me fail. So what it means, my prediction is, because overall majority is for the pass, right? That is how we decide the combined result of different decision trees. Now, how does random forest work? As I have mentioned, we build different decision tree. Each tree predicts, and final output is done by majority voting. ठीक है. Benefits, as we already know, that high accuracy, because we are having majority votes, we are training different models with different data sets, and your if there is some missing value also, or you have missed some data, that can be also handled. Because हमारे पास, for example, if I am checking out on some phone, it is a good or not, maybe I have missed some feature which is bad, but other person may be have highlighted that feature, that this is not a good feature, right? So one model can skip some things, but all models cannot skip, right? So it is robust also to noise or unwanted values, so automatically the accuracy increases, right? So then we have real life analogy on this only, that if I want to get recommendation whether to get a surgery on particular thing based on the diagnosis, I would take the recommendation from a single doctor or multiple doctors. Obviously I would take I would do my diagnosis from a single doctor, but before doing the surgery I would take the recommendation from different two or three doctors whether to do this major surgery or not. I would not randomly go and lie on a table and do the surgery, right? So I would take the suggestions from multiple doctors. That is how your decision tree, a random forest work, that we combine the predictions of expert decision trees and go with the majority, right? So when to use what? When we use decision tree, when we are going for clear explanations, clear predictions, or you can say small decisions where rule based decisions, logic based decisions can be taken, we can use decision tree. But when we want higher accuracy, we are creating some systems with large data sets, or consistency also matters, we go with random forest, right? So this was your decision tree and random forest. This is the scanner which is already shown. This is the scanner for orange application which I have shown. So I have skipped it. Then we have industry applications. So as I gave you the analogy of the doctor's example, similarly in healthcare, these models are used in disease risk prediction, in diagnosis support, in transportation where we are seeing it, in traffic prediction, in e-commerce where we are seeing in Mintra, we get product recommendation, right? In customer behavior prediction, in Netflix, we are getting the predictions. In banking, we can see loan approval, which we discussed in the whole session, right? So you can see we have in every sector, we have different examples. Himanshi says, can you show the screen? Himanshi, this screen you are talking about? Okay, done. Okay, so let's move further. Okay, so we are on the last activity of today. So guess the model for today. I will show you a scenario. You tell me it is a decision tree or random forest. A school needs clear rules for scholarship eligibility. They must explain decision to parents. Guess the model. Which model is preferred here? Which model is preferred here? Decision tree or random forest? Let me see the chart. Rakshita says decision tree. Khalid says random forest for rule making. Sakshi says decision tree. Priyanka says decision tree. Okay, let's see. So it is decision tree because we only have to explain the rules to the parents. That is not a hardcore accuracy or hardcore thing to do. So we can go with the decision tree only for this scenario. Let's move on to next. An edtech company predicts which student will complete the course. Accuracy is very important. Which model? Decision tree or random forest? What do you think? Khalid says random forest. Tejaswini says random forest. Priyanka says random. Okay, a lot of people with random forest, right? Because here it is mentioned accuracy is very important, right? Last, we have a bank wants high reliable fraud detection. What do you think? Decision tree or random forest? Random forest, decision tree, random. Sakshi says random. Okay. So we have random forest because we want high reliability is required. So hope it is clear that difference between random forest, when to use where, what, which algorithm is preferred for which purpose. So this was all the algorithms for supervised learning. Hope it is clear. So let's move on to the last activity for today. Quickly scan the QR code for this and fill out the form. Once done, mention done in the chat. Himanshi, you have answered the season tree for the last one. Himanshi, that is random forest. Reason being reliability is important there. So wherever accuracy, reliability is main, we use random forest. Everyone, please scan the QR code, fill out the form so that we can go on to the Q&A for today. Once done, mention done in the chat. Make sure this is a sort of your attendance form also, so you fill it properly. Okay, I can say few people with done. Valid done. Others, hurry up. 30 seconds more. Manchi says, okay, I can see a lot of done. Great. So this is what we have learned today, that how supervised learning maps label data, input and output. What is regression classification? Difference between linear, logistic, KNN, decision tree, and random forest, when to use which model and which can give you more accuracy, right? Now your work is try the orange application, build linear regression, decision tree, and random forest. All three models using the orange app, right? Try that. And that's it from my end. If you have any questions, you can ask in the chat. I'm looking at the chat. If you have any questions, you can ask in the chat. I'm there to answer. Then we will wind up for today. Any queries? Manshi says next class kab hogi, ma'am? Next class would be on 11th. Okay, let me stop sharing the screen. Okay, pausing for 30 seconds more. If you have any queries, you can ask. Then we are ending with the session. Thank you. Thank you. Okay, so we are winding up the session. Thank you so much for joining. See you in the next session. Thank you, everyone.